My name is G, and today I wanted to give a quick demo and overview of some of the work that I've been doing with Costas in regards to um, locally manufactured small wind turbines. So there are three main goals to what we're trying to do here. So we have recipe generation, which is outputting some tables that go with Hugh Pigot's wind turbine recipe book, that'll really help people assemble together their wind turbine. There's a 3D visualization aspect to it, and that's the part I'm going to focus on in the demo. And we also want to export certain parts to be CNC milled or laser cut, certain flat wood and metal parts. So like I said, I'm going to focus on the visualization aspect since that's the part that I've been focusing on as of late. And what I've been doing is I've been trying to figure out what components we would need and how they interface together, because what we ultimately want to do is somewhere in the OpenAFPM.net website, we're going to have the ability to visualize the wind turbine that it's suggesting that you make with certain parameters, certain magnet-based parameters, as well as parameters that come from a furling tool for the tail, and also certain user-based parameters in case maybe you need to override, you want to override the size of your magnets or something because you may have magnets of the size already on hand, something like that. And so let me share with you a quick diagram that kind of shows the different components that I've created. So primarily there's two different components. There's a server-side component that contains the FreeCAD model for the wind turbine and a script that assembles together all the parts. For example, there's two rotors, but you only have to design one rotor in the model, and the script will basically duplicate that and then assemble it correctly. And then we have a client-side visualization component that's written in JavaScript. It's using a library called 3JS, which is for rendering 3D animations using WebGL. And I'm calling the visualization repository OpenAFPM CAD visualization. The server-side component with the FreeCAD model in Python is called OpenAFPM CAD Core. And I built a third component called OpenAFPM CAD Desktop App. And it's basically acting like the OpenAFPM.net website would. So it allows you to enter in those parameters, the three groups, the magnet-based parameters that come from this tool, Imagine AFPM parameters, the furling parameters that will come from a furling tool, and some user-based parameters that somehow the user will be able to enter in from here. And so instead of trying to figure out how to set up the OpenAFPM website locally and kind of recreate this, it was just a lot easier to create a small little test harness application. And so that's what OpenAFPM Desktop App is it's just a quick little desktop application built using Electron.js, which is a technology that allows you to create a desktop application using web technologies, so HTML, CSS, JavaScript. And what it basically is it's a giant form that allows you to enter in these parameters. It'll send them to the server and pass them into the OpenAFPM CAD Core component. And then what the OpenAFPM CAD Core component outputs after it assembles together all the different parts for the wind turbine based on the parameters, it'll output a wind turbine OBJ file. And what that is this is just a file format for containing a 3D model, so it contains information about all the vertexes, the edges, the faces, like the 3D geometry information. So it's just a big fat file that contains the information that the client-side component needs to know how to render that wind turbine that was created. So let's go ahead and give a quick demo of this. I'm going to go ahead and start up the OpenAFPM CAD desktop app. And like I said, you can see it's basically a giant form that contains those three groups: Imagine, AFPM, Furling, and User. And there's also a drop-down that contains three options: T-shape, H-shape, and star shape, the three different variants for the wind turbine. And as I select these, you can see the different parameters in the form will change to sensible default values. For example, star shape, using a rotor disk radius of 349. T-shape, by default, we're using 150. And we can, of course, if we wanted to, just for testing purposes, like start overriding some of these. But I'll leave it as is. And I'll click Visualize down at the bottom. And it'll take a second. And so what that did was it sent all those parameters to the server, to the server-side OpenAFPM CAD core component, and then it assembled all the parts together for the wind turbine, and this knows how to make the request for the wind turbine OBJ file that contains all of the 3D information for the model. And so you can see I can pan around using the right click of the mouse. I can view different angles with left click. I can zoom in, zoom out, all that good stuff. I have explosion controls on the right hand side here to create space between the parts for easier viewing. I can also toggle the visibility of certain parts. And maybe I get lost here and I can't really find the model anymore, which can happen if you're not careful. I can click Reset View and that will take me back. You'll also notice that as I hover over certain parts, I'm getting a nice tooltip that's telling me what the part is called. So yeah, again, this is just mainly for me, or for anyone who might work on this in the future, to quickly test the client side and back end component for visualizing the wind turbine. Just facilitates rapid testing. And yeah, that's all I have for the demo. Thank you for watching.